Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. On. In this tutorial video, I'll go through this another kind of titrations. This is called thermometric titrations. Thermometric, something to do with thermal, something to do with temperature. We're going to be using thermometer to measure temperature, change essentially, or calculate temperature change from the temperature that we measure using the thermometer, and this will enable us to work out or determine the end point for this titration. That's why it's called thermometric titration. Without further ado, let's get started. So what do we have here? So this is the question. So I'm not too sure if I will be able to do the picture-in-picture, but what P is aqueous potassium hydroxide, Q is sulfuric acid. So P is potassium hydroxide, and P has to be pipette out. This is a pipette, P-I-P-E-T-T-E. So I pipette P out, and I pipette 25.0 cm3 pipette, 25.0 cm3 pipette of P, which is potassium hydroxide, into a plastic cup supported in a beaker. So the plastic cup here actually refers to this styrofoam cup. Styrofoam is this kind of like soft surface thing, S-T-Y-R-O-F-O-A-M, styrofoam cup. It's pretty unstable on its own, so that's why we have to support it on a beaker. Now we're going to pipette that out. So before we use the pipette, we always have to rinse it with distilled water, but the one you're provided in the exam usually is pretty clean already. I'm just going to take that extra precaution and rinse it with some distilled water. So I've got some distilled water on the outside. I have to wipe it dry first before I pipette out a little bit of P, because I will have to wash the pipette, rinse the pipette with the solution that you're going to fill it in. So this is P, goes in the pipette. I would have to wipe the outside a little bit clean, so that I'm just doing the S, which is sucking out the solution. So I'm going to rinse the pipette with the solution that I'm going to fill it in. I don't need a lot, I just need to do rinsing. Okay, so that was done rinsing. Even when you are doing an actual titration, the usual titration with the indicator, you also have to do something similar. So it has the S and the E and the A buttons. The A basically is what you use in order to compress the air, and then you're gonna stick this empty pipette now into the solution and then press S, and then I usually personally prefer to do it at a slight angle, so I'm holding this at a slight angle. Somehow it just feels a bit faster, but don't know about you. Once it's there, you can see there is a line around this region here, so I have to press E in order to get 25.0 cm3, and I have overshot that, and this is just, nah, that doesn't look alright. That one is alright. Okay, I'm gonna eject a little bit, and now this is 25.0. Well, I don't have a white surface behind me, but this is perhaps the best I can do. It's gone just below that now, but it was perfectly fine just now. So a little bit, and then I'm gonna eject a little. Oh, I'm gonna eject a little bit now. Okay, probably won't show you every single time, but you get a line there that is just below the thing there, and somehow I got an air bubble now. Well, it was perfectly fine. Okay, trust my word for it. Okay, take my word for it. And then I press E, and then this thing will slowly come down as I'm ejecting the 25.0 cm3 of P into the styrofoam cup. So take out the pipette filler very gently, rotate it instead of pulling it out like that. Okay, rotate it as you're pulling it out, and just like gravity does its job, you don't have a conical flask here, you have a styrofoam cup, so don't poke it too hard, not like when you poke the glass, but tap, 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 and that should get rid of the last few drops. Okay. Now, after I've got prepared 25.0 cm3 of P there, I need to measure the temperature of P to the nearest 0.5 degrees Celsius. Typical of O-level and also A-level chemistry practical, when you use a thermometer, you record it to something 0.0 or something 0.5. This is called to the nearest 0.5 degrees Celsius. This is the bulb of the thermometer at the end there. Stick it in there, and it's well supported since the styrofoam cup is supported inside a beaker. Leave it there for a while before you record the value, because it just came from outside the air, and depending on where you are in the world, you might be in a cold room, cold country, you might be in a hot room, hot country. Give it a while before the thermometer actually equilibrates and actually settle to the actual temperature of the solution P, which you've got in there. Okay, now put Q into a buret. This is a buret, B-U-R-E-T-T-E. You know this run from 0 to 50.0, 1 decimal place for O-level and IGCSE level. But of course, if you are A-level students, you know that you need to do buret reading to 2 decimal place. I'm just going to focus on the 1 decimal place because I am specifically preparing this tutorial video for the O-level and IGCSE level 14 to 16 years old chemistry students. Before you use a buret, I typically always wash the buret with a little bit of distilled water. Make sure you wash the bottom as well. And then roll it out and remove all the distilled water. But just like the pipette, you also have to rinse it with the solution that you're going to fill it in here. I will have Q in the buret, so I put a little bit of Q in here. Just a little bit for washing. Okay, I don't need a lot for washing, so it will take around 5 cm then. Make sure you allow it to pass through the bottom because you're washing the bottom bit with this solution as well. Roll it around. And then open the tap so that the washings could all just go through like that. Okay? After that, I am filling in the buret with the actual solution Q. So I already closed my tap, so I will make sure that nothing will be leaking. So my hand is pretty steady, so I should be alright. I'm just going to fill this up to 50.0. Sorry, I mean fill it up to 0.0 so that, okay, then I'll read it from 0.0 up there. But I haven't opened the tab yet. You must open the tab to allow this solution to flow out. And now it's completely filled up the volume at the bottom there. I'm now below 0. I'm going to fill it up some more. That is not very good. Let me just add a bit more. Okay, now this thing, if I read just below the meniscus, I should have gotten a white towel, but if I just read below the meniscus, that one is 0.0 cm cube, 1 decimal place from the buret reading. Now I think I'm ready to read the temperature of the solution P, the potassium hydroxide. Just now, this one read as 22.0. Okay, hopefully you can see it better. I don't think you can see it that well. Let me put a contrast behind it. Not too sure. If I put a tissue paper behind it, would it make it better? Let's see. Okay, no, I don't think it makes it any better, but I don't think it makes it any better at all. Hang on, let me just read it again and try to convince you. That is 22.0. So hopefully you can see the 22.0. Trying to find the best angle for this. There's no white background behind it. 22.0. Yep, you can hopefully see the silvery line now. Well, it's not really silver inside, it's actually, I think it's mercury inside. And what happened then is you got 20 at the bottom, and you got 30 on top, so you're reading from the bottom to the top. There's 21 and 22.0 to the nearest 0.5. There's 22.0 degrees Celsius. I'm just going to write down and record my temperature into this column here. So I've got a series of experiments. Experiment number, and then the volume of P. That was the one that I pipette out. That was the potassium hydroxide, I believe. P was potassium hydroxide. P was potassium hydroxide. That goes in the cup. and I started out with 25.0. In fact, all of them prepared out 25.0. I'm just going to change the volume from the buret from 5.0 to 10.0 to 15.0, etc., etc. But what I have is initial temperature. Initial temperature just now was 22.0 degrees Celsius. Initial meaning at the beginning. So that's why I fill in 22.0 degrees Celsius there. I am now going to add some distilled water, because what they want me to do is measure 5.0 cm³ of Q into a measuring cylinder. So I have a measuring cylinder. I should wash this with some distilled water. Okay. After I wash it with distilled water, what do I need to do? This is a 25 cm³ measuring cylinder, not very accurate. I'm going to pass 0.0 all the way to 5.0 because I just want 5 cm³ of this buret reading. Okay, so we'll pass it very, very gently. So let's see, you should be able to see my view here. So I'm just going to pass it, and I just need 5.0. So I will pass it, and then I will be slow at around 4.0. So I will slow down now, and then I'll do drop by drop because I am accurate using a buret. Okay, a buret is really, really accurate to 1 decimal place. As you can see now, this one is, can't really see it probably. Nope, let me just zoom out a little bit. This one is now, the background is terrible actually. This one is now 5.0 because I started from 0.0, so I have put in 5.0 cm³ of this solution acid, the sulfuric acid in here, and then I have to make it up, add water until I get 25 cm³. So this is called serial dilution. I have 5 cm³ of that thing from the buret, and I have the remaining 20 cm³, which is just distilled water. When I add distilled water up to 25 ml, I do not want to squeeze it all the way until 25 ml. I want to squeeze in so that it's fast, but then when you reach around 20 something, do not go fast. Instead, open the bottle and start using a dropper. This is a dropper. You add drop by drop towards the end, just like you make up a stock solution. You do drop by drop towards the end because you don't want to miss it. You need to get it accurate, well, as accurate as the measuring cylinder allows you to be. So just be able to do it. And measuring cylinder is not the most accurate thing in the world, but at least you can get it to 25 ml, 25 cm³. That's the best you can do. Alright, now we're ready to pour this mixture into the plastic cup, the styrofoam cup containing P. Let's just read the temperature again because it's important. It's still 22.0. It's still 22.0. So I'm gonna put it in there now. Okay. And then stir it with the thermometer, measure the highest temperature reached. So the temperature is slowly increasing. It is now around 25, 26. Not too sure if you can see it clearly. I don't think you get to see it very clearly though. Okay, but it is increasing in temperature. So just now was 22, now it's around 25, 26. So I stir it for a bit. I need to record the highest temperature. So my eye is looking down that level, or I can flatten it up and then read at this level. So that is 26.0 degrees Celsius. So I read 26.0 degrees Celsius. Let me just lift that up so that you can see it clearly. I'm gonna hold it against this background and hopefully you can see it. Nope, that doesn't help at all. Does it help? Maybe not. Okay, it's 26.0. I think the white background helps a bit better. I should really grab a white towel, I guess. That is much better. So white background, you get 26.0. Okay, so you get the 26.0. So you see the silver, the line inside the thermometer. 26.0. Okay. So I'm going to record that as the highest temperature, 26.0 degrees Celsius. When you do on your calculator, the calculator will calculate temperature rise, final temperature minus the initial temperature. Oops, sorry. Where was it? Nope, that doesn't work out quite well. Final temperature minus initial temperature. When you press 26.0 minus 22.0, you will get 4 on your calculator. That's because your calculator cannot tell you the decimal places. When it's 0.0, you need to use your brain and think a little bit and include the 0.0 because all of the temperatures are to the nearest 0.5 degrees Celsius. Okay, so without showing you everything on the screen right now, I'm just going to continue the rest of the experiment. Empty the plastic cup and rinse it with water. So just rinse it with water. Rinse it with water. I am just going to rinse it with a bit of distilled water. So it's now empty. And then I'm just going to wash my thermometer with a bit of distilled water. And then I'll just wipe my thermometer clean. Alright, now I'm still going to pipette out 25.0 cm cube of the potassium hydroxide. That was solution P. So we still use 25.0 cm cube of these. So pipette that out. Pipette 25.0 cm cube of these in every single one of the experiments. So that is 25.0 mil, 25.0 cm cube. So project it out into the styrofoam cup. So there are how many experiments to do? There are 6 more experiments we have to do. So I have to be a little bit faster in this experiment. So we are not doing drop by drop. We are just mixing things together. So it will be a bit faster than the normal titrations once you get the hang of it. Okay. Put all the solution in there. Hold it at an angle. Tap, 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 tap. This is styrofoam cup. Do not poke it all the way through. It will produce a hole. All right. Now I have 25.0 cm cube of solution P, which was the potassium hydroxide. Leave the thermometer in there and only read the initial temperature before you're about to do this, okay? Just now we have 5 cm cube from the buret and then we make up the rest with distilled water. The second experiment is use 10 cm cube from the buret. I started from 5.0, so I should stop at 15.0 because 15.0 minus 5.0 is 10.0 cm cube. So I'm just going to put my measuring cylinder down there. Just to double check, I still have, oh no, looks like I now have, oh yeah, it's still 5.0. So I will go fast until I reach around 14, and then I will go slow and do drop by drop. So 5.0 to 15.0 is 10.0. Okay, now I will go drop by drop just to be safe. And that is now 15.0. So I started from 5.0. It is now 15.0. So that is 15. Oops, you can't really see that well, but trust me when I say there's 14 and 15 and 16, so there's 15.0. So 15.0 minus 5.0, that is actually 10.0 cm cube in there. So 10.0 cm cube there. I'm going to add distilled water. We're going to top it up to the same volume, so 25 ml. But I will do it fast until around there, then I slow down. And then I will do it drop by drop because we want to get to the 25 ml. Being careful because we cannot overshoot it and take it out. It doesn't work that way. Dilution doesn't work that way. Once you add excess water, you can't really just take it out like that. You have to do drop by drop when you want to do dilution or make up a stock solution. So there's 25 ml in there. And 25 ml is 25 cm cube. We are ready with this thing, which I have left the thermometer in there for a while. And we're going to record the initial temperature. Now it is 22.0 as well. Okay, hopefully this one will enable you to read the temperature, but I doubt it will be that clear. Where is the line? Where is the line actually? Can't really see the line, can I? Okay, hopefully that is as clear as it could be. It's around 22.0. 22.0 is my initial temperature. As with any experiment, I always have to write down as I record it because I will make mistake if I don't record it. Now mix them together. Mix them together. Stir it with the thermometer. And then look at the temperature rise. So the temperature is rising. I wish I could capture everything, at the same time, but I can't. Hopefully you can see that the temperature is rising. Trying to get the best angle so that it could enable you to read the temperature, but I doubt I can. I doubt I can actually. So I'll probably just convince you by reading the value myself. This one is actually 29.0. This one is 29.0 degrees Celsius. 29.0 degrees Celsius is my highest temperature rise. I could give it a bit longer. So 22.0 to 29.0. Your calculator will show you 7, but it's actually 7.0. Yeah, there's no further change. It's already reached the highest temperature. It's 29.0. So that is 29.0 minus 22.0, 7.0 on the calculator. Repeat the whole thing again. Rinse it out. I'm going to rinse my thermometer as well. And then what we do is we're going to pipette out 25 cm cube of the solution P. Solution P, do not mix up your solutions. There is your potassium hydroxide. Pipette out 25 cm cube of these into the plastic cup. We still have 5 more experiments to finish off, so we gotta do this a bit fast now. The earlier bit was just for you to familiarize yourself with the procedure, but once you're okay with the procedure, you should be able to do this fairly quickly. So I'm going to talk less and do more now. Now I have 15.0 in my buret, but the next experiment I need, it's not 15, it's only 12 cm cube from the buret. So I need 12 cm cube from the buret. I start with 15.0, I need 12.0, so 12.0 plus 15.0, that will give me 27.0. So I should start at 27.0. Tap, 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 don't poke your buret. Don't poke your styrofoam with the pipette, sorry. Put the thermometer in there, and as I mentioned just now, here the volume of Q in experiment 3 is 12.0, and you need 13.0 cm3 of water. We don't care too much about the water because from the buret we flow out 12.0 cm3, but I started from 15.0. My initial volume is 15.0. I want 12.0 cm3, so 12.0 plus 15.0, this gives me 27.0. So I should slow down around 26. So just to show you, so pass it out. I should slow down around 26. So I'm just doing drop by drop now. Okay, now that is reading 27.0. I started from 15.0. Started from 15.0. That was 15.0 just now. Now is 27.0. So 27.0 to 15.0. That is 12.0 cm cube in there. You can read it again, but measuring cylinder can never be that accurate. So again, top it up with distilled water until close to the 25 cm cube mark, but then do not keep on squeezing from the bottle. Instead, what you do is you do it drop by drop at the end, because that is what you do to make it up to 25 cm cube or 25 ml. So read below the meniscus, Okay, now that is 25 ml. I've topped it out with some water. Now I'm ready to read the initial temperature of the stuff I prepared out. So this is also 22.0 degrees Celsius, 22.0. I wish I can show you what actually happened, but I can't. I mean, I can, but So here the temperature suddenly rises, and it rises all the way to 30. I don't know if it's going to continue rising. 30 degrees Celsius. So it's reading 30 degrees Celsius right now. Let me just move the thermometer a little bit here. Hope to show it to you. 30 degrees Celsius. Where is 30 degrees Celsius? The lighting doesn't help that much. Yeah? Never mind. I better go. It's alright, okay? Trust my word for it. It is reading 30.0 degrees Celsius. So that's my highest temperature rise. So the temperature increases because this reaction, neutralization between an acid and an alkali, it releases heat to the surrounding and the temperature of the solution goes up. This is an exothermic reaction. H plus and OH minus, they just form bond. They form the OH covalent bond when they form water. Neutralization, ionic equation, but you don't need to break any bond. Bond breaking, not happening. Bond forming is exothermic. That's the only thing happening. Therefore, it's an exothermic reaction. 30.0 minus 22.0, I get 8.0 degrees Celsius temperature rise. Now let's clean this up. Just gonna rinse it with some distilled water. I'm just gonna rinse my thermometer with some distilled water. Okay. We're trying to work a bit faster now because now that you know what is going on, you should be able to, follow through what I have done. This is solution P. So again, we prepared out 25.0 cm cube of this solution P, which is the potassium hydroxide. Yep, there's 25.0 cm cube of that. Now we have to get 16.0 from the buret. So the last I left off is 27.0 cm cube. So my initial volume is 27.0, but I need 16 cm cube from there, 16.0. So 27.0 plus 16.0, I will get 43.0. So I need to stop at around 42.0, and then I will slow down. Put the thermometer for the solution P there. This is solution Q. My measuring cylinder is empty now, so put it back underneath the buret. I started from 27.0, but now I want 16.0 cm cube of this solution Q. 16.0 plus 27.0, I will get 43.0. So I will flow this until 42. Then I slow down and do it drop by drop so that I get 43.0 cm cube reading on my buret accurately. Initial volume plus how much you need is going to be the final volume. That is how you do titration most of the time, right? I hope. So 16.0, so stop at 42. Well, stop at 43, but I'm going to slow down at 42. Okay, I will lift this up a little bit since this is not my eye level. This is my eye level. I will do it drop by drop. Okay, now it reads 43.0 on my buret. So 42, 43, I read below the meniscus, 43.0 minus the 27.0, that is 16.0 cm cube of solution Q. Okay, what I do next is I want to put in just a bit of, well, maybe I don't want to overshoot it, so I'll just use this dropping pipette. Okay, I'll just use this dropper to add the water. I don't want to overshoot the 25.0. Well, not 25.0 because measuring cylinder is never that accurate, but I don't want to overshoot the 25 cm cube mark. So here, I'm very close to that now, reading below the meniscus, reading below the meniscus, reading below the meniscus. So now that is 25 cm cube of this. I need to read the initial temperature as you're used to this experiment. Again, it reads 22.0 because to the nearest 0.5 degrees Celsius. Put that in, stir it, and record the temperature rise. So here, the highest it's gone to is like 31.5. I wonder if it's going to go up if I stir it so that the heat is distributed evenly. I need to stir it gently with the thermometer. It is still reading 31.5, so it's in between 31 and 32. So 30 is there, it's in between 31 and 32, so this is 31.5 degrees Celsius. So it had the same initial temperature, but it's gone up to 30.5. Did I say 30.5? No, I said 31.5. This is in between 31 and 32. So I read it as 31.5 degrees Celsius. 31.5 degrees Celsius minus the 22.0, I get 9.5 degrees Celsius increase in temperature. We're ready to move on to the next one, but remember my buret is now down to 43. I need to top up my buret reading. The P goes to the pipettes, the Q which is the sulfuric acid goes in the buret, so I just top up my buret. I'm just going to make my life easy and just level it down all the way to 10.0 cm cube. So that is 9 and that is 10. So that 10.0 plus something else is going to be easy enough for me to read. That's all. So rinse your cup. Rinse your cup with some water. And I'm going to rinse it with some distilled water. I'm going to rinse my thermometer with some distilled water. Okay, what now? We're going to pipette out another 25.0 cm cube of solution P. Solution P is your potassium hydroxide. So pipette out to another 25 ml. I think I'm left with the last three reading. So we need to speed up a lot more in order to complete this experiment on time, obviously. So altogether, I think it pretty much takes about the same time as an actual titration. Probably a bit longer, but it's all about perseverance and your passions, and of course how fast you can get things done once you get the idea of things. Now the next volume of Q from the buret is 18.0. 18.0 from the buret. So I start from 10.0 plus 18.0. I'll stop at 28.0. Now the pipette is empty now. 1, 2, 3, 4, 5. 18.0 plus 10.0 is 28.0, so I will stop at 28.0, but I will slow down when I reach 27. So I let it flow. I let it flow in there. I only slow down at 27. I want 18.0, which is 18.0 plus 10. That gives me 28.0. This is my end goal, but I stop just before that so that I can do drop by drop because I want 18.0. That means exact volume from the buret. I wonder, oh yeah, okay. I thought I missed it. No, I haven't missed it. So I will slow down now. Okay, let's do drop by drop. Okay, that reads 28.0. So that is 27, and this is 28. So I started from 10.0 plus 18.0. They give me 28.0. Like I said, I'm just gonna do using the dropper so that I don't overshoot it. Very close to the end already, very close to the 25 mil mark. I just don't want to overshoot it. This is just making it up to 25 mil, so I don't really have to work out the volume of water added because they're going to add up to 25 cm3, 25 mil there. I made a mistake. I should have let the thermometer stay in the solution in the measuring cylinder for a little bit, but that was my mistake earlier, but I doubt it will change that much. Most of the time, the initial temperature has read 22.0, so I'm just going to read the thermometer now. It is still 22.0, so it's still the same initial temperature. Put it in there, mix the acid and the base together, stir it gently with the thermometer, and read the reading on the thermometer. It's gone up, it's shot up, it has increased in temperature, it's gotten hotter. It's now 31.5, 32.0. I wonder, no, it's in between 31 and 32, it's 31.5. It's between 31 and 32, it's 31.5. So it's exactly the same reading as my previous result. So this is the difference of 9.5 degrees Celsius. So just like that again. Okay, not to worry too much. We are collecting data. We'll worry about processing the data later on. So of course, the usual thing is throw away everything. We still have 2 more experiments to do, so let's speed up a little bit. So rinse your thermometer. I'm gonna still have 2 more. Wow, okay, this thing is pretty long actually. Didn't realize how much time it would take me until now. So let's see if I can finish the other 2 very, very quickly. We still have a graph to plot at the end of this kind of questions. So this is 12 marks for the actual practical, pretty much the same as the marks you would get for a normal titration. So you need to be wise enough with your time management when you see a question like this for your actual practical. So rather than the actual titration where you would do 1 graph and 2 exact titration, I think this one actually takes a bit more time than the normal titration, and it still gives you 12 marks for the whole question, which is quite unfair, but you get what you get. It's one of the many practicals that you need to do. Okay, put the thermometer in there, and now I need 20.0 from the buret. I have 28.0 plus 20.0, so I will stop at 48. I will stop at 48.0 because 20.0 plus 28.0 give me 48.0. I make sure that I still have enough because this runs up to 50.0. So I'll stop near to 48 and then do drop by drop to get to 48.0. I've got my thermometer stuck immersed in the P there, so that should equilibrate to the initial temperature later on. So I need this to be 48.0 because overall I'll be pumping in 18.0 cm³ of this solution in the buret. So slow down and do drop by drop. Okay, so that is 48.0. There's 48 because there's 47, 48.0 minus the 28.0, which I stopped just now. That is 20.0 inside the measuring cylinder. I need to be careful. I don't want to, run anything over, because if I run anything over, I will have to start from the very beginning, and I don't have that luxury of time. So do not try and knock anything over, because you will not have time to repeat your serve, I guess. So here I'm just making it up to 25 cm³, and that is 25 cm³. I'm ready to mix it. So this one reads 22.0 as well. Put it in, and my temperature has gone up, and it is not as high as before. It's only around 31.0. 31.0 is the highest temperature. I started with 22.0, I end up with 31.0. That is 9.0 degrees Celsius difference only. Okay. So obviously in the real exam, you're just collecting data, but make sure the temperature are all to the nearest 0.5 degrees Celsius, which include the temperature change to the nearest 0.5 or 0.0. Well, to the nearest 0.5 means you must have 0.0 or 0.5 degrees Celsius. Now we're on to the last thing that we're going to do. So just very quickly, rinse it with distilled water as well. Alright, okay. So the last thing I'm going to prepare out another 25 ml, another 25 cm³ of solution P. Do not get your solution mixed up. It's going to be a disaster if you get your solution mixed up. This is P, potassium hydroxide. You read the questions before you actually do the experiment so that you will not get confused. You do not have the luxury of time. As you could see, I'm rushing towards the end. I'm trying to portray to you the actual situation. If you're doing this actual practical, this is how rushed it will be towards the end there. It's not like the normal titrations where you are supposed to get similar kind of titer. This is a different kind of titration. This is called thermometric titrations. You don't know what the endpoint is going to be because you're going to use the data to plot the graph where they intersect later on. Okay, I have to top up my buret as well because the last thing I'm going to do is 25.0 cm³ in here. So I need 25.0 cm³ in the buret. Instead, I have only a couple of last drops in there. So Q goes in the buret. I wonder if I have enough. Oh yeah, I do have enough, okay? But in exam they said that each student should have a specific quantity, so you don't have time to repeat any of these at all. So I'm just gonna put this down to. So I've got it down to 23 cm cube. So that one is 22. This one is 23.0. 23.0 plus 25.0 is going to give me 48.0. So very clearly, I'm just going to stop at 48.0. So again, this is empty, kind of empty, I guess. So stop at 48.0. Oops, sorry. So this is the very last thing. We're just getting ready for the very last experiment that we're going to do to monitor this temperature change when this acid reacts with this base. Any acid reacts with any base in a neutralization reaction. Every single neutralization reaction has a H plus aqueous combining with OH minus aqueous. It's going to be exothermic reactions. Neutralization is an exothermic reaction. Temperature of the solution, which is the surrounding, will go up because the system releases energy to the surrounding. The surrounding gets hotter. You see an increase in temperature. So I started from 23. So 23.0 plus 25.0 is 48.0. So nearly there, nearly there. I don't want to read below the meniscus, so I'm just going to lift this up a little bit. So then I'm reading with my eye level. So 48.0, and this 25 mil, 25 cm cube. Oh, I forgot to read the initial temperature actually. Yep, it's still 22.0, pretty much the same as all the other experiments. Mix them in, and it's gotten a bit hotter because it's obviously exothermic. And it is reading 30.0, 30.0, 30.5, 30.5 there. Okay, so 22.0 to 30.5, that is 8.5 degrees Celsius difference. So for that 12 marks, I've just done a series of experiments where I have pipetted, the same volume of the KOH, and then I run a different volume of the sulfuric acid from the buret, and I top it up with my distilled water. But the total volume of the sulfuric acid and the distilled water changes because I'm doing serial dilution. I'm slowly getting it more and more concentrated because previously I used lesser of the acid and I used more of the water, and now in the very last experiment I just have completely the acid on its own without any water. There's just the actual concentration of that solution we're provided with. From here, you're expected to plot a table, and this table is temperature rise on the y-axis, and on the x-axis you have the volume of Q. The volume of Q comes from the buret, so that is your volume of Q that you run through from the buret from 0 all the way to 25. You're gonna have put in the points, and you're gonna get an intersecting graph, and that intersection between the two lines, which you extrapolate, and that intersection is gonna tell you the end point. Okay, that's gonna tell you the end point where they intersect. The end point is the titer there from the buret there, and you can use that for your titration calculation. Hopefully that makes sense there, and that is pretty much everything I want to convey to you in this thermometric titration demonstration or thermometric titration experiment which I've just showed you. Okay, so thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel, and follow me at ptet.chemistry. There's at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram. And do consider upgrading to the silver tier membership to access pretty much everything else on my channel that at the moment are available for members only. So to access all those, so do use a VPN, or if the membership is available, if the membership option is available in the country, you can just upgrade straight away and access these silver tier materials straight away. Okay, and enjoy them. Thank you for watching. Do enjoy learning chemistry, and see you again in the next tutorial video.